So what we will be covering, and I just wanted to give you a brief overview of what you can expect today, is we'll give you an introduction, right? We'll also talk to you about our teaching methodology, where we'll actually walk you through 2 case studies, right? Which should give you a very fairly good understanding of what you can expect out of the course, right? And then towards the end we will have a Q&A session. Okay, so let me start off now with the introduction. My name is Jahnavi, and I have over 13 years of experience in marketing analytics and strategy in the credit card financial sector, primarily with American Express. Okay, and I have considerable experience in developing and deploying large-scale marketing data capabilities like customer offer recommenders or mobile app response prediction models, as well as digital marketing analytics like paid search. And over the years, I have also been instrumental in building and leading large machine learning teams. Over to you, Kishore.
Thanks, Janvi. Hi all, I'm Kishore. I've done my MBA from IIM Calcutta, and that's where I discovered my passion for analytics. And since passing out of IIM Calcutta, I've been in the data science field ever since, starting with financial services domain and then moving to e-commerce domain. And then currently I'm working as a retail industry consultant. Throughout this time, I've worked on various technologies within data science and also worked on improving some of the existing algorithms so that we can even come up with better algorithms than some of the algorithms that are there in the industry. And that has been my passion throughout, which is simplify the process of data science and push them into production.
So, Manu is unable to join us today, but let me give you a brief introduction of Manu. So, Manu is the co-founder and chief data scientist at MathLogic, which is an analytics, data science consulting and training firm. He has over 15 years of experience in analytics consulting, working with some of the global organizations in retail banking, wealth management, telecom, entertainment, non-profit sector, among others. And he is also a corporate trainer. He has trained more than 2,000 plus professionals in machine learning, including newer programming languages like Scala and Spark.
So let me take it on behalf of Prakash then. Prakash has been a double PhD within some of the analytics related fields, where he has done a PhD in industrial engineering in University of Warwick and University of Wisconsin, and he has over 10 years of analytics consulting experience. He has also IP in /patent within this field, where he used that patent to start one of the companies within this field. He has also written a book on data science and is also the author of one of the packages in R, which is used for optimization.
Okay, so, I think before we get into the case studies and, we talk more about our teaching methodology, we wanted to just give you a flavor of, why we feel data science is very relevant, not just today, but more so in the future, right? I'm not going to go into things like, data science is the most hot profession right now, and the salaries that a data scientist earns. I think most of you are aware of that. But what I really want to talk about is that, data science is all pervasive right now, and it is going to be more pervasive, in the future. Whether you look at financial industry or you look at marketing, I myself had worked in marketing analytics where, we extensively use data science, healthcare, manufacturing. There are a lot of, even in the government sector or agriculture, data science and AI and robotics is used. So, just some of our thoughts on that, and, I'll not spend a lot of time, but Kishore, if you can move to the next slide. So, for reads, we have listed down some interesting articles which can give you a flavor of where all data science is being currently used. from AI to agriculture to there's an article by from Wait by But Why in terms of what is a revolution in terms of artificial intelligence. So take your time, read through this. Can we move to the next slide, please?
Yeah.
Okay. We also wanted to, take this opportunity and give you some thoughts around what really differentiates a data scientist from a data analyst and a data engineer, right? So if you really look at it, and broadly, these are the three core skills that are required in this field, right? So there is obviously math and stat skill. So, because a lot of the algorithms require a knowledge of statistics or linear algebra, so this is a core skill. Along with that, programming, computer science is definitely another core skill. And there is also domain and business expertise. So, I'm going to talk about this more in detail in one of the case studies. But knowing about, like, if you're building some, tool, machine learning tool for the healthcare sector, knowing about that sector is also important. So these are the three areas or skills required. Now, if we look at, if we talk about a data analyst primarily has, math and stat skill along with the domain and business expertise, right? So looks at the trends in that particular industry. Say in marketing, it looks at the trends and then use math and stats to come up with insights, right? A data engineer uses math and stats and programming and computer science to really come up with different, like, visualization tools or the other kind of tools. A data scientist has to have all these three areas or three areas of knowledge or skills, right? So a data scientist has to understand the domain, like, has to be able to understand the business problem or business business objective, to be able to know the data associated, and I'm going to talk about that in more detail, and then design the algorithm or the technique which can help solve the business problem, and also be able to communicate it clearly, right? So a data scientist actually is able to do all of these different areas. Okay, and if you go to the next slide,
Yep.
broadly, these are the key activities of a data scientist. So first, of course, defining the business problem, right, the business objective. Then it's about, understanding what kind of data that is available, processing that data, making sense out of the data, then doing a data analysis that, what is the data that, what is the data telling us, right? And then creating a model or a predictive model which will help solve the business objective, and also prototyping it. As I said, it's also about communication and prototyping it. So, and most importantly, it's not a static field, right? This is a field where, a data scientist has to continuously, keep updated with the latest trends in technology, because things are changing very fast. We are not just restricted to machine learning right now. We are actually now moving into deep learning, computer vision, AI. So a data scientist has to continuously keep oneself updated with the latest trends in technology. And I'm not going into too many examples here. I'm going to explain all of this through a case study towards the end of the session.
Getting to the motivation behind our start of deep learning track, if you think of the previous slide that we have looked at here, which is where we are trying to compare data analyst, data scientist, and data engineer, I would like to think of it as, what are the tools that we are using, what are the statistical techniques that we are doing, and then what are the use cases that we are solving. And if we think of it, what a data scientist does is a combination of tools which comes under a bit of programming / computer science, combination of techniques / statistical techniques, which comes under math or stats part, and then finally domain / business expertise, which comes under what are the use cases or what are the problems that we are solving. So in essence, a data scientist is someone who has the knowledge of all the three, that is tools, techniques, and how do I convert a business problem into a mathematical problem and go about solving it. And given that we are someone who has been with the industry for quite some time now, close to 10 years, and having seen quite a lot of use cases within the industry, we thought we should be filling the gap in terms of having a course which talks not only about tools, not only about statistical techniques, but also the use cases. And that's where there are three key pillars based on which we have designed our course, which is the first one being bridging the gap between theory and practice. And the reason behind that is, as I said, given that we have seen quite a few industry use cases ourselves and have been quite extensively involved, we did notice that there is quite some gap in terms of how industry solves a problem and how most of the students have been learning how to solve problem, if at all they're learning by themselves. So that's where we see a huge opportunity in terms of, one, quickening their learning process, and two, simplifying their learning experience. Because if you think of it, there are almost close to 10 to 15 algorithms that are there right now, and people would always ask, which algorithm should I be applying for this type of problem? And two, what is this algorithm really doing in the backend? And that's where, in order to simplify this process, we have coded all the algorithms in Excel so that people can really understand what's happening under the hood of each algorithm, instead of just giving a very high detail of what the algorithm is doing. I'll explain how this process works in by explaining one of the algorithms in a few moments. And also quickening the learning process, what we have done is we have invested close to or hundreds of hours of our time in simplifying the curriculum as much as possible without losing any amount of quality. That means we are giving pre-reads of whatever we are going to be discussing in the class, and we are also going to share the codes of the various use cases that we are talking about, which are close to 15 different case studies. And also we'll be supporting our students in terms of discussion forums and handling the queries, and all of this instruction would be happening where with a live instructor teaching just like the way we are doing now, and also making sure that everyone in the class is involved by having a limited class size for our classes. So in essence, what could one expect from this 8-weekend course? They should be very familiar with how the industry solves a typical problem by working on multiple case studies. They can be very confident about some of the algorithms, and the only few algorithms that we have left out for this data science course are the algorithms that were invented very recently, that is over the last 2 years. But any algorithm that is not there over the last, that has been invented prior to that, we have included in our course. Now, getting to how we typically teach an algorithm, in order to help explain that one, we'll talk about one of the algorithms called gradient descent algorithm. By the name of it, this algorithm sounds a lot complicated, but what's happening under the hood of this algorithm is quite simple the moment we translate this data into an Excel sheet. In order to do that, let me walk you through the Excel sheet in itself. But before that, let's look at what's the problem that we are trying to solve. And the problem here is, given a house size in square feet, we should be able to predict what is the price of this particular house. We do understand that house price is not just influenced by house size, but it also influenced by a lot of other factors. But for now, we'll just assume that only house size is the one that is influencing house price and nothing else. If that is the case, how do I go about converting this prediction problem into a mathematical problem and solve this? And that's where, let me walk you through the Excel sheet of this one. Let's say we have a historical set of house sizes that are given, and a historical set of house prices at which they were sold. Given these two sets, we should be able to predict if a house size is, let's say, 2,200, we should be able to come up with what is the expected price of this particular house. In order for us to do that, we should be able to come up with some form of mathematical equation here. And for now, we'll be assuming that the equation will be somewhere close to y is equal to a plus bx. In an ideal scenario, in a typical class, we would have given a lot more detail about what's happening in a linear regression, what are the various things that one should be considering, and so on. But now that we have a severe paucity of time, we'll quickly talk about what's happening here. Y is equal to a plus bx. We are coming up, or the problem now translates to come up with an optimal set of a and b values here. So where y is the price and x is the house size. Now, the first thing that we are doing is we notice that x and y have a very different set of magnitudes. You would notice that x has a range between, let's say, 1100 to 2450, whereas y has a range between 199,000 to 405,000. And given that these two have very different magnitudes in itself, we should somehow normalize them to similar magnitudes. And there are various techniques to do that, and one of the techniques is called min-max standardization, which is nothing but take each of the values, so let's say 1100, subtract it from the minimum value, which is C18 1100, and divide it by the max minus minimum value of this particular column. There are many other ways of doing that, and but for now we have just used this way. And after doing this, you would have noticed that for x value, or for the x column, the values are ranging between 0 to 1, and also for y column, the values are ranging between 0 to 1. So that means somehow using this min-max standardization, we have normalized for the different magnitudes of each of these columns. Now that we have normalized for the magnitudes of each of these columns, the next step that we are going to do is fit a line like this where y is equal to a plus bx. In a typical scenario, all that we would have done is within, let's say, one of the tools, let's say R, we would have just said, use a function called GLM, give me the y parameter, give me the x parameter, and the output would be a and b. While that works, in a typical industry scenario, we would expect the candidate, or expect the person to know how a and b values are getting generated. And that's where the Excel demos, or looking under the hood of each of the algorithms, helps, because we also understand what's happening behind each of these algorithms. So in this particular case, the algorithm works in this way. We'll initially start off with random values of a and b. And so in this particular case, if I randomly chose a to be 0.45 and b to be 0.75, you would notice that when I fit an equation like this, y is equal to a plus bx, this value in cell G31 translates to a, which is 0.45 plus 0.75 into 0. So that translates to 0.45, this is 0.62, and so on. And now that we came up with some prediction here based on the randomly chosen a and b values, there will be some error. And the error is nothing but the difference of these two whole square. And the reason why we would do a whole square is to get around some of the issues of the sign of error. We'll talk about that in more detail when we would have covered about linear regression and what are the different ways in which we would evaluate the error of an equation. But for now, if we assume that error is nothing but actual minus predicted whole square divided by 2, our total error in this particular case, where a and b are initialized randomly, is 0.677. And now is where gradient descent comes into picture. If we randomly change again the value of a from 0.45 to, let's say, 0.4, we notice that the total error has gone down from 0.677 to 0.525. So essentially what it is saying is a should be reduced from the current value to some other value so that overall error is reduced, And at the same time, if I randomly change 0.75 to 0.7, error still reduces and it goes down by a little bit. And so that also means that as B decreases, error is reducing. So, or the initial point here is suggesting us to reduce the values of A and B in order for us to reduce the overall error. And if you would have looked at a typical textbook scenario, you would have noticed some formula called partial differentiation of error upon A, dou E by dou A, and that's pretty much what we have done earlier, where we have said let's reduce A by 0.01 when we change A to 0.44 or 45 to 0.44, our error reduced by a bit. So that's where, and that's what dou E by dou A here is doing, which talks about what happens to the error as I change either A or B. So in this particular case, now that we have established that both A and B should be going down, as you would have noticed here, the next step is let's reduce A and B by some value. And the value that we are going to change it to is going to be based on this particular formula here, which is new A is equal to old A minus a small value. In this case, we have chosen it to be 0.01, and we call that as a learning rate, multiplied by the change in error when we change A by a little bit. And that's this value here, 3.3. So now that based on this formula, we're going to come up with a new A value, which is 0.42. As you would have noticed the linkage here, it's the old A, which is 0.45 minus the learning rate, which is 0.01 into K41, which is this value here. Now we have come up with new values of A and B. And now if we have noticed the error reduced from 0.677 to 0.553. And if we have, and now that error has reduced, we would do the same drill again, which means we will look at what is the error when we change A by a little bit and what is the error when we change B by a little bit. And these are the values that we would have gotten. And now update for the new values of A and B again, where new A is older A value, which is 0.42 minus some learning rate, which is 0.01 into the overall error change when A changes by a little bit. So now the value of A gets updated to 0.39 from 0.42 and the value of B gets updated to 0.72 from 0.73. And ultimately it will keep on updating till the values of A and B do not get updated anymore. And that's the optimal values of A and B that minimize our overall error. So that's a little bit about how we explain the total functions backend. In a similar manner, we would have explained about all the functions within the class. Yeah, if you have any questions, do post them over chat and we'd be happy to take them. And over to you, Janvi.
Okay, okay, thanks, Kishore. So, I was talking about the role of a data scientist, and often, we see that data science is about the algorithm or the technique, right, or some tool or programming language. Actually, that's not the case. In fact, if you look at any data science assignment, the first step is always about understanding the business problem or objective, and then comes the algorithm and the technique. Right? And that is the reason why you will see, and Kishore also talked about it, that in our course there is a lot of focus on industry case studies. So we will be covering industry case studies extensively in our course. And let me walk you through an example and explain what I mean by that. Okay, so here is an industry case study on recommender, restaurant recommender, right? Now, you must have seen many of these restaurant search and discovery providers like Zomato, Yelp. What they do is that they provide personalized recommendations of restaurants to customers based on customers' likes and dislikes, right? You can see one such example here where it says top 25 recommendations for you. And if you recall, this is very similar to the product recommendations that you get on Amazon when you go and buy something there, right? So it's on the same logic. Okay, so let's first try to understand what kind of business problem these restaurant recommendations help solve. Okay, so let's say there is this restaurant aggregator like Zomato and Yelp, which wants to increase customer engagement, existing customer engagement, and attract new customers. So in this case, this is the business objective or the business problem. Now, one of the ways of really tackling this problem is to provide personalized recommendations of restaurants to customers, allowing them to discover new restaurants, right? Or discover restaurants that they have not visited before. And as you can see, this surely can have a positive impact in increasing customer engagement.
Yep.
So till now we have defined a business objective. Now it's time to look at the existing data, right? What kind of data is available to the aggregator? So the data available could be table booking data, as you can see from the table on the top. So customer 1 in the past has booked table at restaurant A, B, and not C through the aggregator. You can also have customer data like, what is the profile data of the customer in terms of age, cuisine preference, location. There could be also restaurant profile data like type of restaurant, right? Cuisine, Italian, Chinese, American, the size of the restaurant. However, this data has to be processed, right? It cannot be used as is. You can see there is a lot of missing data here. There's a lot of gibberish data here. So this data has to be organized, has to be cleaned, assessed for data sparseness, and then only it's ready for usage, right? So this is the second task of a data science assignment, and that a data scientist has to do. So what I was saying, that we have defined the business problem, right? We have understood the data. Now it's time to focus on the algorithm which will be used to solve the business objective or business problem. Okay, so in this example, the algorithm that we will be using is a recommender algorithm. Okay, so I'll not get into the details of what a recommender algorithm is, but very briefly, a recommender algorithm predicts the preference, usually given by a score, of a user for an item. The user in this case a customer, and item here is a restaurant. Okay, so according to this algorithm, in this example, customer 1 prefers restaurant C over B and A, and hence the algo will recommend restaurant C to the customer if the customer has not visited the restaurant before. Okay, thus allowing the customer to discover a new place, new restaurant according to his liking. So this is how it works, and hopefully, by this you can appreciate how an algorithm is a means to solve for a business problem or meet a business objective. And before I wrap up this case study, because I've talked through all the steps involved, it's also, there's another point that I would like to highlight here is that it is also very important to choose the right algorithm or technique for a business problem. And therefore, it is very important to understand the intuitive meaning behind what an algo is doing. Okay, so let's try to understand that in this example. Let me take the first case. Okay, so let's say customer 1 is of similar profile to this group of customers given in light blue. It could be of same age, right? Now this group of customers prefer restaurant C, right? Maybe the highest number of table bookings by this group of customers has been on restaurant C. Okay, so the algorithm, the recommender algorithm, based on this data is likely to predict that customer 1 is likely to have a higher preference for restaurant C and thus recommend restaurant C to customer 1. So now you can see this is how we can understand the intuitive meaning behind what an algo is doing. And what I'm trying to convey here is that This way, we will be able to better use an algorithm to meet the business objective and not just blindly implement it. And these are the key aspects that we would be focusing in the industry case studies that we would be covering as part of the course. Okay, so we will be covering close to 15 case studies as part of the course. This is not an exhaustive list here, but these are some of the examples. So that wraps up the second case study, let me quickly go over the course logistics with a duration of 8 weeks. Classes will be 2 to 3 hours on weekends, and the class starting time is 7 p.m. India time, 8:30 a.m. CST. And very quickly on the course format, courses, as Kishore mentioned, will be conducted online. The course material codes will be provided after every class, and there will be pre-reads before the start of the class. There will be case studies and take-home assignments every week. Take-home assignments will be discussed in the following week's class, and there will be full coursework support. We will be setting up a discussion platform on Piazza, and all coursework related and other queries will be handled through that platform. So, that essentially wraps up the session. We now want to open up for any question answers. So, please, if you can put your questions on the chat box, we can take them up one by one.
Yeah, I see a question from Sanjeev, which says, how do we remove data noise effectively? To answer this question, Sanjeev, there are multiple things that could be considered as noise in data. There is no one thing that might be noise. For example, if you were looking at restaurant data here, so the moment you notice a location being named Z like this, someone might think of it as a noise. Someone might say this is a signal where all these Z's indicate something. So that's where one of the questions that we would have to think of is first of all, is this a noise or is it a signal? If at all it's a noise, there are multiple ways of solving this problem, and there are multiple forms of noise as well. For example, having weird ways of specifying a value is noise. Having question marks or having null values could be considered as noise in some way. So in all these cases, depending on which case it is, there are different ways of handling that particular data. So for example, just to give you an intuition, if let's say age as a variable is missing in a particular in a particular data, we might fill these missing values with mean of the rest of the values for age or median of the rest of the values for age. And getting a little more complex, there is some algorithm called as k-nearest neighbors that helps in imputing it in a much more appropriate way. So those are the few things that we would be discussing in our case studies anyway. But to put it succinctly, there are different ways of solving this problem depending on what type of noise it is. I see another question from Shobin, but before letting that question know, Sanjeev, if you have more questions on that, do type in on chat message and we can talk further. There is a question from Shobin that says, what are the prerequisites for joining this course? Do you need anything in statistics, anything in calculus or programming? Janvi, do you want to take that?
Yes, Kishore. Thanks, Shobin. So as I said, I think for this course is meant to be as a stepping stone into data science, right? So what we would primarily expect is, the basic understanding of any programming language. We don't expect any proficiency. So we just want a very basic understanding, some sort of familiarity, I would say. with any programming language, and similarly some sort of familiarity with math and linear algebra. So we don't expect any proficiency. We don't expect a lot of hands-on experience. We want some familiarity. But apart from that, this course is open to all, because the way we have structured the course and the way we will be teaching it, it will be pretty hands-on. It will be from the basics. So anybody can attend this course for for that matter.
Yeah, just to add to that, the same partial differentiation that I've showed you earlier, if you have noticed, we have also explained it using what would be the error value if I change a by a little bit, and that's what a partial differentiation is also doing. So that's the level of detail without having all the math rigor, but explaining it from the first principles that we are doing. And that's where we do not expect people to be very good at calculus or statistics, but at the same time we expect people to be familiar with what is linear algebra, how do you do, let's say, some simple matrix multiplications, or how do you do basic programming. And by basic programming I would have meant we should not be talking about for loops, what is if else, or during the class. We expect people to know a minimum of what is a for loop and what is an if else, while we would also teach it, but we would expect a little around this one. But apart from that, I think, as I said, this is based on first principles, so you should be gaining as much as possible in the class itself.
So I think, if you don't have any more questions, and we are top of the hour, but please feel free to drop in an email. Kishore, if you can go to the next slide, the last slide. So we have put in our email IDs where you can drop in an email to ask any questions. We'll also circulate this deck. So please feel free to do that. We are starting the course from 13th of May. So, please do register soon, because our seats are limited. Seats are limited. We are not, we will be restricting the batch size to not more than 15. I think there's a question from Samir. Just check that.
No, I don't.
Okay, yeah. Yeah, we can get we are recording the session. So the question is, can we get a video recording of the session? So we are recording the session, and we are actually planning to post it on the website, but we'll let you know when we do that. So definitely, yes. Okay, great. So, okay, so then we can wrap up the session, but as I said, please feel free to drop in emails to us for any questions that you may have. And thank you so much for joining us for this session today.